Hey guys, it's Mr. Katz. This is going to serve as the video for class, but one of my favorite substitute, actually one of my favorite people, Miss Lee, will be there. Uh, for the first couple slides, we're going to go over the homework from SLT 6. Some of them you're going to want to pay more attention to because they're a lot more important. Other ones were more thinking questions that if you didn't quite get, it's not as important, but we will talk about it when I get back. Just make sure you pause and read, and if someone can help explain, the answers, if someone doesn't get it, that would be awesome. Here's number one, and the answer is obviously in red, so just pause the video and make sure everyone understands it. Here's number two. Go ahead and pause the video. This is not as important as number one, but still, I would think people should have got the major idea. Remember, these are kind of like sample answers. They don't have to be exact. Here's number three. Make it a little bigger. This basically is talking about the fact that if you have a square or rectangle and just stretch it out, these bases are going to still remain the same. What's going to change is this is going to move a little bit to the right, but this will also move a little bit to the right. So if you take the parallel plane, this length will be the same as this length. And at any point, this length will be the same as this length because it moved over a little bit to the right, but so did this. So that's why you can use the formula base times height, which is the same thing as the square rectangle for a parallelogram. Here's number four. Basically, this is just talking about, you'll pause it and read it, but this is just basically talking about if you swing these triangles around, they're essentially the same triangle. The height's going to be the same in all of them, and the base is going to be the same in all of them, so they'll basically have the same area. I've said the word basically a ton of times, but hopefully you get the point. Here's number four. This is not as important. Well, I mean, it's important, and hopefully we have gotten this, but it's more of a perspective thing. If you didn't notice, what the bases were, what the height of each prism was, then you might have been a little bit confused, but hopefully by looking at the answer, someone could explain. Here, these two parts are really important. The wording and the work, please make sure you take a good look at what they did to solve both these problems. These are really important because you're finding the volume. And again, an oblique cylinder has the same volume as a right cylinder because of Cavalari's principle. And the last one I want you to look at and pause is this one. This was actually something that we did the day before. This was problem number 2. Take a good look. To solve this problem, I called the two sides of the right triangle x and x, and I figured out what x was by this formula using the Pythagorean theorem. Then I knew the area of this triangle by multiplying the length times width times 1/2, because area of a triangle. And then if I knew that the area of the other base was 8, I can say 8 equals a side squared because it's a square, so both length times width will be the same. And you get that one of the sides is root 8. All right, so today's lesson is on SLT 7. Mrs. Lee was going to give you guys a couple of different shapes. Make sure we put them back when we're done. And there's a lot of prisms and non-prisms. There's cylinders, there's cones, I believe there's spheres, and the rest should be prisms, whether triangular prisms or right rectangular prisms. What would you guys define to be a prism? So go ahead and pause the video and let's take responses. And then when you're done, go ahead and we'll give you the answer. So a couple things you should have said with the prism. First of all, they have parallel congruent bases. So the bases have to be exactly the same. And the lateral sides, which means the things that connect the bases, are going to be basically parallelograms. Which they could be rectangles, they could actually be squares, but they could also be parallelograms, and I'll show you that in a second. And again, prisms could be oblique or they could be right prisms. And whether they're oblique or right, you can still use the same volume formula. Right. So go ahead in your groups and decide. Here are 3 rectangular prisms. This one looks to be actually a square prism, but which one do you think would hold the most? Go ahead in your groups and decide 1, 2, or 3. And when you're done, go ahead onto play it, and then go on to the next slide, and then you could actually compute and see if you were right. Here are the actual lengths and widths of each of them. Go ahead and find the volume of each of them. Remember, volume is area of the base, or big B, times the height. Go ahead when you're done and just share to make sure everyone has the same answers for volume. So one of the things that I wanted to show you is that when you have lateral faces, these green and red are the lateral faces of the prism. Here's a triangular prism. Notice as you move the prism up or down, longer, these lateral faces could actually become parallelograms. When it's a right prism, they look to be like exactly straight rectangles. But you're going to notice as you shift them down, they could actually become parallelograms. Now, examine all the shapes on your desk, and now put them in descending order, left to right, which you think would actually hold the most. And this is more of a thinking. We're not going to actually go over the exact answer. Just write down from left to right what you think. Is it the cone that would hold more than a rectangular prism? Most of them would probably have about the same height. So I'm just curious, and we're going to talk about this first thing tomorrow. Which do you think would hold the most? Or which one would have the largest volume? So volume formulas of all the shapes. If it comes to a point, which would be a pyramid or a cone, the volume formula is actually 1/3 BH. Now notice that's a big B, which means area of the base times the height. So if you're dealing with a cone, the base is a circle, so it's going to be 1/3 pi r squared times the height of the cone. Otherwise, every prism will have the formula. We've already gone over this. Big B times H, or area of one of the bases times its height. The sphere is one exception that doesn't follow these volume formulas. The sphere formula is 4/3 pi r squared. So again, that's 4/3 pi times radius squared. And notice the radius, remember, of the base. You could leave pi as the variable pi. You don't have to actually multiply it by the full pi in your calculator. And you could leave your answers in the form of like 102 pi or 101 2/10 pi. Make sure you have those formulas down. Go ahead and pause the video until you have them down. All right. So Mrs. Lee is going to hand out our surface area and volume of prisms. But what I want you to do, we're not learning surface area right now. So for each of these, don't worry about finding the surface area. I want you to find the volume of every one of these. So when the questions ask you to find the surface area, just ignore that. On the back of each worksheet are also the answers. So you can check right away whether you have the right answer. Most of these are rounded. So they're rounding to the nearest tenth. So make sure you round to the nearest tenth. But also go ahead and make sure you have the exact answer. If it's in terms of pi, or not in terms of pi, but make sure that you round and you give the answer in terms of pi. All right? And then this will be what you're doing both today in class and tonight for homework to finish up.